The novel FlashForward by Robert Sawyer is a science fiction novel taking place at the CERN laboratory in Geneva, Switzerland. The action focuses on the ALICE experiment at the Large Hadron Collider. ALICE is a real experiment, and the Large Hadron Collider is a real accelerator facility, brand new and just being brought into existence. What happens to kick off the action in the novel is that a certain kind of collision occurs in ALICE. Very energetic lead ions are accelerated in the Large Hadron Collider, or LHC. And when they collide within ALICE, all of humanity blacks out for 2 minutes and 17 seconds, and it has a vision of themselves as they will be far into the future. We will carry out such experiments in ALICE, but we don't expect any such effect on the consciousness of humanity. The main protagonist in the novel is a Canadian physicist working at ALICE. I am based at Lawrence Berkeley National Laboratory in California, but I also happen to be a Canadian physicist working at ALICE. The purpose of ALICE is to study a state of matter that existed just a very small fraction of a second after the Big Bang. This is a fundamental state of matter called the quark-gluon plasma. The main LHC program is based on colliding protons at extremely high energy. In the search for a new particle called the Higgs boson, perhaps there's one, perhaps there's several of those. The search for new classes of particles called supersymmetric particles. That will be what LHC does many months of the year. But for about 4 weeks per year, the LHC will accelerate and collide very massive nuclei, nuclei of lead atoms, which are about 200 times the mass of a proton. For some time, there was an idea that lead-ion collisions, in particular the very intense electromagnetic field surrounding them, would be an efficient way, and in fact a unique and clean way to produce the Higgs, and perhaps ALICE would have a chance to see it. But it turns out, after people looked at the calculations in more detail, the rates of that process are really very low, and it's unlikely that that really would be the way that people will find it. In the novel, working at ALICE is depicted as a few people sitting around a computer screen twiddling knobs. The collisions happen and out pops whatever it is they were looking for, in this case the Higgs boson. The reality is quite different. Experiments at modern colliders are massive affairs. They take 15 years from conception through design, through construction, to bring into operation even before any science is done. And that activity is done by a very large and international team of scientists, technicians, students, and so on. There are about 1,700 scientists and technicians and students from the U.S. working at the LHC. It is really a massive effort of many universities, about 95 universities in the U.S. from 31 states. There are huge efforts also from all European countries, many countries in Asia, also in the Southern Hemisphere. It is a truly international effort. So why doesn't the Higgs boson just pop out at you when you turn on the machine and collide protons at these enormous energies? The first reason is that it's a very rare process. It's expected to happen 1 in a billion proton collisions, and there are other things that are much more mundane physics that happen much more frequently. And the other answer, very important answer, is that the patterns generated by the Higgs boson can be mimicked by what we call background processes, more mundane physics that, if you don't look carefully enough, looks a lot like the Higgs boson. So the accelerator, as it's running, the longer it runs, the more detail it accumulates about the Higgs boson and the backgrounds. And just like looking at a digital image in higher and higher resolution with more and more pixels, the more data we accumulate, the better we'll be able to discriminate the signal we're looking for, say the Higgs boson, from noise in the background or other uninteresting things. Science fiction can be very provocative. It can take our current scientific ideas and stretch them a little bit or a lot and make us think about what time means, what space means, what consciousness means. And from that point of view, it's really, really very interesting, and it's fun to see the relationship between science as we do it in the laboratory and what the imagination of a science fiction writer turns it into. Fast forward is certainly fanciful, and we don't expect to cause a blackout of all humanity when we collide lead ions in the Alice experiment. But nevertheless, it's fun to think and talk about.